Kia ora guys, welcome to 12.04 from Alpha on spatial patterns. Now spatial patterns are basically 2 or 3 dimensional patterns. In maths we often do them out of matchsticks so that you can physically build the patterns if needed. Alright, so here we have a pattern. We've got 3 patterns here. The first thing you might be asked to do is draw the 4th and 5th pattern. Now most of you will be able to work that out. Here I've just got 1 square, 2 square, 3 square, and I'm adding on 1 extra square each time. So the 4th pattern will have 4 squares, the 5th pattern will have 5 squares. And then I've got these dots. Now these dots are supposed to be my matchstick heads. Okay, so I'll just go along and put all my dots in. Alright, the second, so there we go. If you could do that, that's an achieved part of it. The next thing you're going to be asked to do is to draw up a table. Yeah, so we're going to put a table here. And the table is supposed to reflect for how many squares and how many matches are needed for each pattern. So what I like to do is I'm going to say number of squares. So I'm going to say S equals number of squares. Okay, so I'm defining my variable. I'm telling the person who's going to mark me that S is going to be the number of squares. And I'm going to say M equals the number of matches. Okay, so that's going to be the other side of my table. I think I might run out of room here. Okay, so first of all, when I have got 1 square, how many matches have I got? So I can just count the heads, can't I? So I've got 1, 2, 3, 4 match heads. Then I go to my second one here. How many match heads have I got? I've got 1, 2, 3, 4, 5, 6. Whoops, for my 2 squares. Then I go down to my third one. It's my third one. How many squares have I got? 1, 2, 3. Put that in. And how many match heads have I got? 1, 2, 3, 4, 5, 6, 7, 8. There. And I think I'll only be able to fit 1 more in. Go down to my 4th pattern. 1, 2, 3, 4 squares. How many match heads have I got? 1, 2, 3, 4, 5. Oops, this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, again, that's just an achieved question. This is where we need to start thinking about our pattern. So what we're saying is, if I have got 4 squares, I'm going to have 10 matches to build it. If I've got 3 squares, I'm going to have 8 matches to build it. 2 squares will take 6 matches to build it. And we need to try and come up with a rule. So what would my rule be? If I'm trying to say M equals, the number of matches equals what to do with the squares. Now the first thing we do is what we refer to as the first difference. What's the difference between 4 and 6? Well, I've added 2 to it, haven't I? What's the difference between 6 and 8? Oh, I've added 2. What's the difference between 8 and 10? Oh my goodness, I have added 2 again. So my first difference, okay, my first difference is in this case always the same number, and it's the number 2. So when I go to write my formula, I know, even though I'm adding 2 every time, my multiplier is going to be 2. So for every 2 squares, okay, plus something is going to give me the number of matches. Now, even though I realise that we're adding 2, and down here I'm saying multiplying by 2. The reason I'm multiplying by 2, because what I'm actually saying is 4 times 2 is going to give me 8, and then I've got to add something to get to 10. 2s, 2 times 3 is 6, plus what is 8? Again, 2 times 2 is 4, plus what is 6? 2 times 2 is 2, plus what is 2 is 4. In every one of those cases, just move it up a little bit here, hopefully you worked out what I was trying to add on. Okay, so I said m equals 2 lots of s plus what? It was 2. Now, that was just because I went through and I said 4 times 2 is 8, plus 2 is 10. 3 times 2 is 6, plus 2 is 8. 2 times 2 is 4, plus 2 is 6. Okay? But we can also use it in a more of an algebraic way. Right? Let's have a look. I might just go to another slide. Alright, so let's look at this more of an algebraic way rather than just a bit of guess and check. Okay? What I'm trying to get to is a format of this. Alright? Now, this m, we later on will start calling it the gradient, but in the case here, it is the common difference. Right? In our case here, the x is going to be the number of squares, and my y is going to be my matches. So I'm trying to find an equation that would be m equals my number of matches, the common difference times my squares plus another number. Right, well that sounds very complicated. I don't know if I made that easier or not. Okay, first of all we go back to this bit here. That common difference was plus 2. Okay, between those two numbers I'm always adding on 2. Now my common difference is equal to 2. So that means I'm going to put this 2 in here. Because remember I said that m means the common difference. Now I need to do a bit of substitution. I can pick any pair from up here and substitute it into this equation to find my little answer at the end there. Now for now I'm just going to say that's equal to c. Okay, because in algebra we like to have all the terms in rather than just blanks or squares. So I'm going to substitute in s equals 1, m equals 4. So when m equals 4, s equals 1, so that's going to be 2 times 1 plus c. So 4 is going to be equal to 2 plus c. So c must be equal. So if I just move this up a bit. So that means I can now rewrite my equation as m equals 2s plus 2. Wow, that seems a little bit difficult. We'll try it on another sheet. Right, let's go with this one here. Okay, now I have got the number of tables, so we'll say tables equals t, and the number of seats equal to s. Right, so if I look at this, I've got one table and I've got 4 people who can sit around it. Then I've got 2 tables and I've got 1, 2, 3, 4, 5, 6 people who sit around it. 3 tables, 1, 2, 3, 4, 5, 6, 7, 8 people who sit around it. Okay, and I'm going to need to write a rule for the number of seats in relation to the number of tables. Alright, so let's go with, we're going to have, first of all, draw up my kind of table, and I'm going to say my number of seats, whoops, let me just, it's not seats, the number of tables in relation to the number of seats. So first of all, I start off with, I've got 1 table, I've got 4 seats. I've got 2 tables, I've got 6 seats. 3 tables, 6, 7, 8 seats. 4, I wonder what it could be. Now, this is where you could draw it again, and in fact we often ask you to draw it again, but you can also look at, see what's happening with this pattern. 4, 6, 8, I think the next one might be 10. 5, I think the next one might be 12. Right, that's easy enough to do. Next, you have to work out the common difference. What have I done from 4 to get to 6? I've added 2. What have I done from 6 to 8? I've added 2. From 8 to 10, I've added 2. From 10 to 12, I've also added 2. Okay, so now I'm trying to find this formula. Remember I said it was y equals mx plus C. That's the standard formula. We want to now use it in relation to what we've got. So I'm trying to say my number of seats equals my common difference, which is my multiplier of 2, times this first column here, which is my T, plus C. Next, I'm going to substitute in one set of numbers. I can pick any set of numbers I want, okay, but they have to be going across this way. So I can pick 1 and 4, 2 and 6, 3 and 8, 4 and 10, but I like 1 and 4 because 1's really easy to multiply by. All right, so now I'm going to say when S equals 4, I'm going to have 2 lots of 1 plus C. So 4 equals 2 plus C. What's my C going to equal? C is going to equal 2. So now my formula is S equals 2T plus 2. Cool thing with algebra, as you all know, is we can now substitute in other numbers and check if it's right. Let's see how good my multiplication is. I'm now going to substitute in 5 and 12. Okay, so when S equals 12, I'm going to have 2 lots of T, which is 5, plus 2. 2 5s are 10, plus 2 is 12. So I know my rule is correct. It's pretty cool, eh? You can also do it for sequences. The key is that this column here, okay, you want it to going up in ones. Anyway, if you're getting a bit stuck, talk to the teacher. Or you can come and see me and tell me you don't really understand the video. I'm happy to do a new one. See you guys.